Installing quick disconnects directly at motors ranging from 1 to 50 horsepower raises serious safety concerns, particularly if they can be opened while the motor is running under load. When a motor is operating, it draws a substantial amount of current. Opening a disconnect switch while this high current is flowing creates a dangerous situation. The primary risk is arcing. When the contacts of the quick disconnect are separated under load, the high current attempts to continue flowing across the gap. This results in an electrical arc, a sustained discharge of electricity through the air. These arcs are extremely hot and can easily ignite nearby materials, creating a fire hazard. The intense heat can also cause burns to anyone in close proximity. Furthermore, the arcing can damage the disconnect switch itself, potentially leading to future failures and increased safety risks. In addition to the fire hazard, opening a quick disconnect under load can also damage the motor. Sudden interruption of current flow can create voltage spikes within the motor windings. These voltage spikes can stress the insulation of the windings, leading to premature failure. In severe cases, the high current can cause the motor windings to overheat and burn out completely, necessitating costly repairs or replacement. The intention to allow unqualified personnel to change out motors quickly using these disconnects further exacerbates the safety concerns. Individuals without proper electrical training may not understand the risks associated with opening a disconnect under load, increasing the likelihood of accidents. Electrical work should always be performed by qualified electricians who are trained in safe work practices and familiar with relevant electrical codes. To mitigate these risks, it is crucial to prevent the quick disconnects from being opened while the motor is under load. Firstly, consider the placement of the disconnects. Installing them in a location that is not readily accessible to unauthorized personnel can help prevent accidental or intentional opening under load. Mounting the disconnects on the back of the motor, as suggested, can be a viable option if it makes them less accessible. However, ensure that this location still allows for safe and convenient maintenance by qualified personnel. Secondly, a more robust solution is to install the quick disconnects within a locked enclosure. This physically prevents anyone from opening the disconnect without first unlocking the enclosure. The enclosure should be clearly labeled with warnings about the potential hazards of opening the disconnect under load. A lockout-tagout procedure should be implemented in conjunction with the locked enclosure. This procedure requires that the disconnect be de-energized and locked out before any work is performed on the motor. A tag is then attached to the lock indicating who performed the lockout and why. This ensures that the disconnect cannot be accidentally or intentionally re-energized while work is in progress. Thirdly, consider using disconnect switches that are specifically designed for motor applications. These switches are typically rated for higher currents and voltages and are designed to safely interrupt the current flow under load. They often include features such as arc chutes, which help to extinguish the arc quickly and safely. Fourthly, implementing a comprehensive training program for all personnel who may interact with the motors or disconnects is essential. This training should cover the hazards of opening a disconnect under load, the proper lockout-tagout procedures, and the importance of using qualified electricians for electrical work. Fifthly, ensure that all electrical work complies with relevant electrical codes and standards such as the National Electrical Code, or NEC. The NEC provides detailed requirements for the installation and maintenance of electrical equipment, including motor disconnects. Adhering to these requirements helps to ensure the safety of personnel and equipment. It is important to communicate these safety concerns to the customer and explain the risks associated with installing quick disconnects that can be opened under load. Emphasize the importance of prioritizing safety and using qualified electricians for all electrical work. Offer alternative solutions that can provide the customer with the convenience they desire while maintaining a safe working environment. For example, you could suggest using pre-wired motor cables with connectors that are rated for disconnecting under load. These connectors are designed to safely interrupt the current flow and prevent arcing. However, even with these connectors, it is still important to follow proper lockout-tagout procedures to ensure that the motor is de-energized before disconnecting the cable. Another option is to use variable frequency drives, or volts, which can provide soft starting and stopping of the motor. This reduces the stress on the motor windings and can extend the life of the motor. VFD can also provide overload protection, which can help to prevent the motor from overheating and burning out. Ultimately, the decision of how to proceed with the installation of the quick disconnect should be based on a careful assessment of the risks and benefits, taking into account the customer's needs and the safety of personnel. It is crucial to prioritize safety and to ensure that all electrical work is performed by qualified electricians in accordance with the relevant electrical codes and standards. Here are some additional points to consider. Firstly, the size of the motor will affect the size and type of disconnect switch that is required. Motors with higher horsepower ratings will require larger disconnect switches that are capable of handling the higher currents. Secondly, the voltage of the motor will also affect the size and type of disconnect switch that is required. Motors with higher voltage ratings will require disconnect switches that are insulated for the higher voltage. Thirdly, the location of the disconnect switch will affect the type of enclosure that is required. Disconnect switches that are installed in wet or dusty locations will require enclosures that are rated for those environments. Fourthly, the NEC specifies the requirements for motor disconnects in Article 430. Specifically, NEC Section 430.102 A requires that a disconnecting means be located within sight from the motor and the driven machinery location. The disconnecting means must plainly indicate whether it is in the open or closed position as stated by NEC Section 430.104. NEC Section 430.109 outlines the types of disconnecting means permitted for motors, which include motor circuit switches rated in horsepower, molded case circuit breakers, and in some cases, an attachment plug and receptacle for smaller motors. Fifthly, when selecting a disconnect switch, it is important to choose one that is listed by a recognized testing laboratory such as Underwriters Laboratories or all. This ensures that the disconnect switch has been tested and meets safety standards. Sixthly, when installing a disconnect switch, it is important to follow the manufacturer's instructions carefully. This will help to ensure that the disconnect switch is installed correctly and will operate safely. Seventhly, regular maintenance of the disconnect switch is essential to ensure its continued safe operation. This includes inspecting the contacts for wear and tear and cleaning the enclosure to remove any dust or debris. Eighthly, remember that electrical safety is paramount. Never attempt to work on electrical equipment unless you are qualified and trained to do so. Always follow proper lockout-tagout procedures and use appropriate personal protective equipment. Finally, if you have any doubts about the safety of an electrical installation, consult with a qualified electrician. They can help you to assess the risks and to develop a plan to mitigate them. Consider the specific application and environment where these motors are used. For instance, in a dusty or corrosive environment, a more robust and sealed disconnect enclosure may be necessary to protect the switch from damage and ensure reliable operation. In applications where frequent motor changes are expected, even with the safety measures in place, evaluate whether the chosen disconnect system allows for efficient and safe motor replacement without undue complexity. Think about the long-term implications. While quick disconnects might seem like a convenient solution for rapid motor replacement, weigh the potential for increased maintenance, the risk of component failure, and the overall cost compared to more traditional, but safer, methods of motor disconnection. Remember that the primary goal is to ensure a safe and reliable electrical system. Before proceeding with any installation, thoroughly review the relevant sections of the NEC and consult with a qualified electrical engineer to ensure compliance and best practices. The customer's desire for quick motor changes should be balanced with the paramount importance of safety and code compliance. Exploring alternative solutions that address both the need for speed and the requirement for safety may lead to a more acceptable and reliable outcome. Always prioritize the well-being of personnel and the integrity of the electrical system. Furthermore, consider the potential for human error. Even with training and proper procedures, mistakes can happen. Implementing redundant safety measures, such as interlocking systems that prevent the disconnect from being opened under load, can help to mitigate the risk of human error. Additionally, clearly labeling the disconnects with warnings and instructions can help to remind personnel of the proper procedures. consider the use of arc flash protection. Arc flash is a dangerous phenomenon that can occur when there is a fault in an electrical system. Arc flash can cause serious burns, injuries, and even death. To protect personnel from arc flash hazards, it is important to implement arc flash protection measures, such as using arc-resistant switchgear, wearing appropriate personal protective equipment, and conducting arc flash hazard analyses. Arc flash hazard analyses can help to identify potential arc flash hazards and to determine the appropriate level of protection required. Finally, remember that safety is an ongoing process. It is important to regularly review and update safety procedures to ensure that they are effective and that they reflect the latest industry best practices. Encourage personnel to report any safety concerns or near misses so that they can be addressed promptly. By prioritizing safety and implementing appropriate safety measures, you can help to prevent accidents and to ensure a safe working environment. Consider the long-term reliability of the chosen quick disconnect system. Will the connectors and enclosures withstand the rigors of the industrial environment? Will they be resistant to corrosion, vibration, and temperature extremes? Choosing high-quality components that are designed for the specific application can help to ensure long-term reliability and reduce the need for frequent maintenance. Furthermore, consider the availability of replacement parts. Will replacement connectors and enclosures be readily available if they are needed? Choosing a system that is based on readily available components can help to minimize downtime in the event of a failure. Also consider the impact on motor efficiency. Some quick disconnect systems may introduce additional resistance into the motor circuit, which can reduce motor efficiency. This can result in higher energy consumption and increased operating costs. Choose a system that is designed to minimize resistance and maintain motor efficiency. In addition, consider the impact on motor cooling. Some quick disconnect systems may restrict airflow around the motor, which can reduce motor cooling. This can lead to higher motor operating temperatures and reduce motor life. Choose a system that does not impede motor cooling. Remember to consult with the motor manufacturer to ensure that the chosen quick disconnect system is compatible with the motor and that it will not void the motor warranty. The motor manufacturer can provide valuable insights into the specific requirements for the motor and can recommend appropriate disconnect systems. Finally, document all aspects of the quick disconnect system, including the installation procedures, the maintenance procedures, and the safety procedures. This documentation should be readily available to all personnel who may interact with the system. It is also important to keep the documentation up to date to reflect any changes or modifications to the system. By following these guidelines, you can help to ensure that the quick disconnect system is installed and operated safely and reliably.